This video is about writing the formula for ionic compounds. On the screen at the moment we can see several different ionic compounds. Here we have sodium carbonate. This is sodium chloride, magnesium chloride, iron nitrate, aluminium oxide, and ammonium chloride. With the exception of ammonium chloride, each of these ionic compounds has something in common. They are all made up of a metal and a nonmetal, or a group of nonmetals. For example, the carbon and oxygen, or the nitrogen and oxygen. The metal in each of these is a positive ion, known as a cation. The nonmetal in each of these are negative ions, known as anions. In order to obtain an ionic compound, a cation must be attached to an anion to form a neutral combination. For example, each of these different ionic compounds have no charge, no overall charge. So this is what you're looking for when you join the different cations and anions together. It's important to note that the metal is always written first and the anion or nonmetal is always written second. The exception was ammonium, which is also a cation, NH4+, and the chloride here being Cl-. Now let's have a look at a typical exam question of writing a particular ionic compound. So here we have three questions. We're looking for the ionic compound formula for copper sulfate, copper sulfate, and copper nitrate. Eventually you will have memorized most of your metal cation charges and your anions. However, in the beginning you might be presented with the two tables such as these. So the top part of the table here is a table of common cations, positive ions, and the bottom part of the table here is a table of common anions or negative ions. So the first thing you need to do is you need to find the copper as a positive ion. Now you'll note here that copper has two different charges, the copper plus and the copper 2+. Now technically this name should have told you the charge. However, if it doesn't, it's okay to assume that it's the most common form of copper, which is copper 2+. So we write down our copper and our charge. Then what we want to do is we want to find out what sulfide is. Now again, eventually it'll come from memory, or if we think about the periodic table and which group it's in, we can work out its charge. But it is down here, and it is telling us that sulfide is S2-. So we're going to write that down. Now if these two ions were to come together as is, the 2+ would cancel the 2- out. So 2+ plus 2- would equal 0. And that's what we're after, an ionic compound with zero charge. So because the two charges are the same but opposite, we can simply write down the formula as copper sulfide. So we have our ionic formula for copper sulfide, and it has no charge. Now we can do the same thing down here for copper sulfate. So again, Cu2+, most common. Sulfate is in the anion table as SO4 2-. So again, our charges of 2+ and 2- are the same. So they will cancel each other out. So we can simply write the formula as being CuSO4. So an ionic formula with no overall charge. Now let's have a look at something where this is different. So we're still sticking with copper. So we've got copper 2+. This time it's nitrate. So if we look in our negative ion side and we find nitrate, here it is here. So it's NO3-. Now we have an issue. The two charges are not the same. We have 2+ on this side and minus on this side. If we were adding them together, we'd have plus, plus, and 1 minus, leaving us with an overall charge of plus. But an ionic compound can't have an overall charge, so we need to get rid of this. Now there's a couple of ways you can do this, but essentially what you're thinking is we've got 2 pluses on this side, we're going to need 2 minuses on this side. At the moment we only have 1, so we will need another nitrate so that we can have the 2 negatives. So we would be writing this as copper, and we want 2 nitrates, but we can't put a number in front of the formula because this is just not the standard way to write it. So even though we want the 2 nitrates like this, what we have to write is copper NO3 and the 2 down here. Now the issue with this is it looks like there's 32 oxygens, so to counteract that we put brackets on. So now we have copper nitrate. Another way to think of it is by cross-multiplying our charges. So we want to cancel this out. So we're going to bring the 2 here, and we're going to bring it down to this side, and this is a -1, which we're going to bring down to there. Now we don't write 1s down, so we can just write copper. Again, we have our NO3, and we can bring our 2 down. We need to put the brackets in to make sure that it's 2 lots of nitrate and not 32 oxygens. And that becomes our formula. Let's have a look at a few more examples. So again, when you're asked to write the formula for an ionic compound, you need to identify the 2 different ions that you have. So for this example, we have sodium dichromate. So we look into our table over here and we see that sodium is +1, so Na+. And we're going to look for our dichromate down here, and we can see that it's Cr2O7 2-, Cr2O7 2-. Now using the concept of we need to form a compound with no overall charge, we can easily see that we're going to need 2 of the sodiums to get a 2+ on this side to cancel the 2-. Or alternatively, we can cross multiply. We bring the 2 down here and the 1 down here. So we end up writing Na2 Cr2O7. Now remember, we don't need to put a 1 because the fact that we wrote it down tells us that there is something present. So this is sodium dichromate, a neutrally charged compound. Now let's have a look at magnesium hydroxide. So magnesium is in our table here, Mg2+, so we write that down. Hydroxide also in our table, down here, OH-. So again, we can think of this as we've got 2+ but only 1-, so we are going to need 2 of these in order to cancel out the 2 pluses. Alternatively, we can take our 2 down here and our 1 down here. So we're going to write Mg, just one of them, the OH, and there was 2 of them. Now here's an issue again. This is suggesting, the way that it's written here, that it is 2 hydrogens. But we know that what we actually want is 2 hydroxides. So to make sure that we're clear, we are going to need to put brackets in, so that we are saying there is 2 hydroxides. So this is magnesium hydroxide. One more example, aluminium carbonate. We can see from our table up here that aluminium is Al3+. Carbonate from our table here is CO3 2-. Now if we were going to try and neutralize these, we've got 3+ and 2-. So we'd end up with an extra plus. So what we really need to do is we need to say, well, we could have 2 of these, which would take that to 6+, and 3 of these, which would take this to 6-. 6+, 6-, and we're neutral. Again, it's easy to cross multiply. We're going to bring the 3 down here and the 2 down here. So we've got Al2 CO3 3. Now, we don't want 33, so what we need to make sure we do is we put the brackets in so that we actually have 3 lots of the carbonate. Again, aluminium carbonate, neutral charge. Thanks for watching.